Could a black hole devour us all one day? There are millions of them out there just waiting. And if we happen to encounter one or make a black hole accidentally, well, you better fasten your seatbelts. Things are really going to suck, literally. What would we see if we got pulled into a black hole? Could Earth orbit both the sun and a black hole? And would we survive spaghettification? Let's find out what would happen if Earth were sucked into a black hole. Black hole basics. The ultimate cosmic vacuum. Before we get into the nightmare scenario of Earth falling into a black hole, let's understand what we're dealing with. A black hole is a region of space where gravity is so incredibly strong that nothing can escape from it. Not matter, not light, not even information. They form when massive amounts of matter get compressed into an impossibly small space, creating a gravitational pull so intense it literally warps the fabric of space-time itself. The gravity is so extreme that it creates what scientists call an event horizon, a boundary beyond which escape is impossible. Once you cross that line, you're done. No amount of thrust, no speed, no force in the universe can pull you back out. You'd need to travel faster than the speed of light to escape, and that's physically impossible according to everything we know about physics. Black holes aren't actually holes in the traditional sense. They're not empty voids or tunnels through space. They're incredibly dense objects with mass, sometimes millions or billions of times the mass of our sun, compressed into a relatively tiny area. Think of them as the universe's ultimate trash compactors, except they compact space-time itself. Types of black holes. Small and absolutely massive. Not all black holes are created equal. There are different types, and they vary dramatically in size and danger level. Stellar black holes are the most common type. These are remnants of supernovae, catastrophic explosions that occur when stars 10 to 20 times larger than our sun collapse in on themselves at the end of their lives. When these massive stars run out of fuel, they can no longer support their own weight against gravity. The core collapses, and if there's enough mass remaining, it becomes a black hole. Stellar black holes are typically about 16 kilometers in diameter. That might sound large, but compared to the scale of space, they're actually quite small. For reference, Earth is about 12,700 kilometers in diameter. A stellar black hole is roughly the size of a large city, yet it contains more mass than multiple suns. Yeah, these stellar black holes are fairly common. There are approximately 100 million of them in our galaxy alone that we know of. That's right. 100 million black holes just in the Milky Way. They're scattered throughout the galaxy, invisible and dangerous. Then there's the much larger and more terrifying competition, supermassive black holes. These monsters have a diameter roughly the size of our entire solar system and a mass greater than 1 million suns combined. Some are billions of times more massive than the sun. One of these supermassive black holes, known as Sagittarius A star, is located right in the center of our galaxy. It's sitting there at the galactic core, about 26,000 light-years away from us, with a mass about 4 million times that of our sun. Every star in our galaxy, including our sun, orbits around this central supermassive black hole. The nearest threats. How close are we to danger? Just 3,000 light-years from Earth is a black hole that's actually visible to the naked eye. Well, not the black hole itself. You can't see something that absorbs all light. But you can see its effects on nearby matter and the companion star it's pulling material from. Thankfully, we're at a safe distance from this stellar black hole and many others like it. 3,000 light-years is incredibly far, about 28 quadrillion kilometers. Even traveling at the speed of light, it would take 3,000 years to reach it. We're not in immediate danger from any known black hole. But that doesn't mean we're completely safe. Black holes move through space like everything else in the galaxy. Stars orbit the galactic center. Black holes drift through the galaxy. And occasionally, a rogue black hole could theoretically wander closer to our solar system. The good news is that astronomers are constantly monitoring space for threats. We'd likely detect a black hole approaching our solar system long before it became dangerous, giving us at least some warning. The bad news is that there wouldn't be much we could do about it except watch as our doom approached. Danger distance. How close is too close? So how close would a black hole need to be to pose a real danger to Earth? The answer might surprise you. Technically, a black hole the size of a 1 mm pin could destroy us if it was close enough to Earth. That's right. Something smaller than a grain of rice could end all life on our planet. This is due to a black hole's incredibly dense mass and extreme gravitational pull packed into such a tiny space. A 1 mm black hole would have roughly the mass of Earth compressed into that minuscule size. If it appeared anywhere near our planet, its gravity would start affecting us immediately. It might not suck us in right away, but it would wreak havoc on our orbit, our tides, our atmosphere, and eventually tear us apart. Our survival depends entirely on whether we've crossed the event horizon or not. You can think of the event horizon as the black hole's point of no return. It's the boundary where the escape velocity equals the speed of light. Anything beyond this point would have to travel faster than light to escape. Yeah, good luck with that. Since nothing can travel faster than light, once you cross the event horizon, you're trapped forever. For a stellar black hole with a mass of about 10 times our Sun, the event horizon would be roughly 30 kilometers in radius. For Sagittarius A star, our galaxy's supermassive black hole, the event horizon extends to about 12 million kilometers, roughly 17 times the radius of the Sun. The approach, Earth starts to stretch. If Earth somehow got close enough to a black hole, meaning we'd moved close to or past the event horizon, the effects would be immediately catastrophic. The side of Earth nearest to the black hole would begin stretching toward it. This happens because gravity follows the inverse square law. The force of gravity gets stronger the closer you are to the source. The difference in gravitational pull between Earth's near side and far side would become extreme. Our atmosphere would start to be vacuumed up first. Air would rush toward the black hole at increasing speeds, creating horrific winds unlike anything Earth has ever experienced. The atmosphere on the side facing the black hole would be stripped away first, exposing the surface to the vacuum of space. Then huge chunks of the Earth would begin to rip apart and follow the atmosphere into the black hole. Mountains would be torn from the ground. Oceans would be pulled from their basins. Entire continents would crack and fragment as the tidal forces became unbearable. If you were standing on Earth during this process, you'd experience increasing gravity pulling you toward the black hole. At first it might feel like a strong wind, then you'd find it harder and harder to stand. Eventually you and everything around you would be lifted off the ground and accelerated toward the black hole along with the rest of the planet's matter. Tidal heating. Earth becomes a pressure cooker. Now let's imagine a slightly different scenario. What if Earth managed to fall into orbit around the black hole instead of falling straight in? Could we survive by orbiting it like we orbit the Sun? Unfortunately, no. We'd experience something called tidal heating, and it would be absolutely devastating. The strong, uneven gravitational pull on Earth would continuously deform the planet as we orbited. Think about how the Moon creates tides in Earth's oceans through its gravitational pull. Now imagine that effect amplified thousands or millions of times and affecting not just water but solid rock. As Earth orbited the black hole, the side facing the black hole would be pulled more strongly than the far side. This would cause the entire planet to bulge toward the black hole. As we moved around in our orbit, different parts of Earth would experience this extreme pulling, causing the planet to flex and deform constantly. This continuous deformation would generate a tremendous amount of internal friction. The rocks and materials inside Earth would be grinding against each other constantly, creating enormous amounts of heat. This would heat Earth's core to absolutely disastrous levels, far hotter than it is now. The result would likely give rise to massive earthquakes as the crust fractured and shifted. Volcanic eruptions would become constant as the superheated interior found ways to release pressure and molten rock. Deadly tsunamis would sweep across what remained of our oceans as the tidal forces pulled water back and forth violently. It would be the trifecta of doom: earthquakes, volcanoes, and tsunamis all at once, constantly with no relief. Earth would essentially become uninhabitable long before we actually fell into the black hole itself. Spaghettification, the worst pasta dish ever. Eventually, whether we fell straight in or orbited first, Earth would begin to stretch in a process known as spaghettification. and not in the tasty, cheesy, tomatoey way. Spaghettification is the technical term for what happens when the tidal forces near a black hole become so extreme that objects get stretched into long, thin shapes like spaghetti noodles. It's also called the noodle effect in scientific papers, which is slightly less disturbing but equally accurate. Let's say you were a superhero and decided to fight the black hole head first. Your head would be closer to the black hole than your feet, which means your head would experience stronger gravitational pull. Your arms would be pulled more than your torso. Your torso would be pulled more than your legs. This would cause your body to stretch out vertically, getting longer and thinner, while simultaneously becoming compressed horizontally as gravity squeezed you from the sides. You'd be stretched like taffy being pulled apart. Let's hope your superpower is elasticity, because you're going to need it. For an average-sized stellar black hole, spaghettification can begin to occur several hundred kilometers away from the event horizon. The tidal forces become so extreme at that distance that objects start to stretch noticeably. But for a supermassive black hole, physicists believe that spaghettification would actually happen inside the event horizon due to its enormous size. The event horizon of a supermassive black hole is so far from the center that the tidal forces at the event horizon itself aren't immediately deadly. You could theoretically cross the event horizon of a supermassive black hole and survive for a little while before the tidal forces deeper inside tore you apart. Eventually, no matter what size the black hole is, anything entering it would be ripped into a string of individual atoms. The tidal forces would overcome the electromagnetic forces holding molecules together, then the forces holding atoms together, until you were literally reduced to a stream of subatomic particles spiraling into the singularity. This would happen to everything that crossed the event horizon. People, planets, stars, you name it. It gets turned into atomic spaghetti. The solar system collapses. Everyone dies. Unfortunately, if Earth were being sucked into a black hole, our whole solar system would likely be doomed as well. The careful gravitational balance between the Sun and our many planets would completely collapse. The Sun itself would be affected by the black hole's gravity. Depending on the black hole's location and trajectory, the Sun might be pulled toward it as well, or its position might shift enough to destabilize all the planetary orbits. The planets would no longer maintain their stable orbits. Some might be flung outward into interstellar space, frozen and dark. Others might spiral inward toward the Sun or toward the black hole. Planets could even crash into one another as their orbits became chaotic and unpredictable. And to add insult to injury, our asteroid belt would likely get pulled toward us or toward the black hole. The asteroid belt contains hundreds of thousands of asteroids, and about 200 of the 552,894 asteroids we've catalogued are more than 100 kilometers across. If just one of those massive asteroids hit Earth, we'd be dead instantly, probably before we even got close enough to the black hole to experience spaghettification. So you might not get stretched into spaghetti after all. Instead, you'd be vaporized by an asteroid impact. Frankly, it's hard to say which fate would be worse. Accretion disk and radiation. Cooked alive. All of the matter from our solar system, the planets, asteroids, comets, gas, dust, and eventually even the Sun itself, would join what's called the accretion disk around the black hole. An accretion disk is a rotating disk of material that forms around a black hole as matter falls toward it. The material doesn't fall straight in. Instead, it spirals inward, forming a disk shape due to angular momentum. As this material spirals closer to the black hole, it gets compressed and accelerated to enormous speeds, sometimes approaching the speed of light. This compression and acceleration generates massive amounts of energy in the form of radiation, particularly X-rays and gamma rays. The accretion disk around an active black hole can become one of the brightest objects in the universe, ironically, even though the black hole itself is dark. So even if we somehow survived all the asteroid impacts, the tidal heating, the earthquakes, the volcanoes, and the tsunamis, we'd likely die from the intense radiation being emitted by the accretion disk. The radiation levels would be lethal long before we reached the event horizon. Believe it or not, astronomers have discovered rare circumbinary planets, planets that orbit two stars at once. This raises an interesting question. Could Earth potentially orbit both a black hole and our Sun in some kind of stable configuration? Theoretically, maybe. But practically no. The extreme tidal forces from the black hole would likely make our planet completely uninhabitable. The temperature extremes, the radiation, the gravitational stress, it would all be too much. And worse yet, the gravitational interactions would be unstable. We'd probably eventually get kicked out of orbit entirely, or we'd get swallowed by either the sun or the black hole. Sorry, but there's really not an outcome where we win here. Past the event horizon, where physics breaks. But let's imagine, just for fun, that we somehow found a way to protect ourselves. Maybe we built some hyper-reinforced space shuttle with technology far beyond anything we currently possess. If we somehow made it past the event horizon alive, we might be in for an even stranger experience than spaghettification. Physics as we know it would change inside a black hole. Things like gravity, the speed of light, even how atoms bind and react might be completely different. The laws of physics that govern our universe might not apply the same way inside the event horizon. The truth is, we don't really know what would happen. We can't get any information out of a black hole. That's the defining characteristic of a black hole. Information can't escape, so we have no way to observe or test what conditions are like inside one. Would we get pulled into another dimension? Would we end up in a parallel universe? Would we travel through time? Would we be crushed into a singularity of infinite density? Or maybe, and this is a wild idea some physicists have proposed, we're already inside a black hole, and our entire universe is just the interior of a much larger black hole in some higher dimensional space. We simply don't know. And unless someone figures out a way to send information back from inside a black hole, we probably never will know. What we do know for certain is that falling into a black hole would be one of the most extreme and destructive experiences possible in our universe. Earth would be torn apart, humanity would be annihilated, and the pieces of our world would spiral into the accretion disk before disappearing beyond the event horizon, lost forever. Conclusion: stay away from black holes. So what would happen if Earth were sucked into a black hole? Pretty much everything bad you can imagine. Our planet would be stretched, heated, torn apart, bombarded with asteroids, irradiated, and eventually reduced to individual atoms before disappearing into the ultimate cosmic oblivion. The good news is that we're currently safe. The nearest black holes are thousands of light years away. Sagittarius A star, the supermassive black hole at our galaxy's center, is stable and far enough away that we're in no danger. We're not going to accidentally fall into a black hole anytime soon. But this thought experiment reminds us just how violent and extreme the universe can be. Black holes represent physics taken to its absolute limit, gravity so strong it breaks space-time itself. They're cosmic monsters that devour everything that comes near them and give nothing back. If you enjoyed this journey into one of the most destructive scenarios possible, subscribe for more explorations of cosmic catastrophes and the extreme physics of our universe. Stay curious and be grateful we live in a relatively calm part of the galaxy far from any black holes.